Okay, we're going to go ahead and continue where we left off in the previous video, 1.4 functions, on example number 8. So here I'm going to show you how to find values where f of x is equal to 0. In the previous examples, we were doing function notation or evaluation, where you plug in a value into the x and you try to figure out what it's equal to, what y is equal to at that given x. So now we're going backwards. We're saying, well, y, remember, y is the same as f of x. We're going to put that as a note here, in case you forgot. Okay, y is equal to f of x. If y is equal to 0, what is the x value? Okay, so we want to find out where this happens. So we're going to go ahead and do a few examples on this one page. It says find all real values of x for which f of x is equal to 0. On a side note, another way to think about this is, what is the x value when your graph crosses the x-axis? So if you remember, on any graph, I'm just going to do a little random one here, something like that, okay? On any graph, these points right here, where the graph is crossing the x-axis, y is equal to 0 at all of these, right? So you can also think of this as finding the x-intercepts, or the zeros, or the roots, or the solutions, or whatever you remember it being called, okay? Let's go ahead and start with letter A. We have f of x is equal to negative 3x plus 5. So what we're going to do is we're going to set this equal to 0, the function, so this part, and we're just going to solve for x. So let's go ahead and do that down here. So here is letter A. Okay, these are going to be the solutions if you want to make a note for yourself there. Okay, and we're going to set f of x equal to 0. I'm only going to write this for the first one. Okay, so what that looks like is like the following. Instead of f of x, I'm going to use 0 equals negative 3x plus 5. So I'm replacing the f of x that was originally there, so this one, okay, with a 0. And I'm going to solve. Okay, so I'm going to solve for x. So I'm going to subtract 5, 0 minus 5 is negative 5. Bring down that negative 3x. Okay, divide both sides by negative 3. And so therefore x is going to be equal to, both negatives are going to cancel out to a positive, so it looks like 5/3, or approximately 1 2/3, which is 1.6, and it goes on forever. So at this point on the graph, okay, I'm going to do just a little sketch here. At 5/3, wherever that is on x, okay, my line is going through the x-axis. So this one, let's see, negative, so it's probably something like this. Okay, I'm going through the point. Hopefully your line is better than mine. But the graph looks something like that, okay? You can check it on your calculator if you don't believe me. All right, next one. So we're going to do the same thing, letter B, okay? And we're going to set it equal to 0. So I'm going to have 0 equals 2/3 x minus 4. And again, I'm glad we have a fraction here. I think I just kind of made this one up. It's not in the book or anything, because a lot of you have had questions about fractions. So I'm gonna try to put more fraction examples in the future, just so we kind of get used to them again. If necessary, I can also do a review video on how to deal with fractions. Okay. So again, all we're doing here is we're setting the f of x equal to 0. So 0 is now taking the place of the f of x, and we're going to solve. So I'm going to add 4 to both sides, like so. Okay, 0 plus 4 is 4. This is 0, so it's gone. And I have 2/3 x. And actually, this one is kind of nice because we don't have to add or subtract. We have to get rid of the 2/3. Okay, so there's two ways you can do this. You can either multiply times the reciprocal, or you can divide by 2/3. I'm going to divide by 2/3 only because I think this is something that we need to review, how to deal with double fractions. Okay, so I'm dividing by 2/3 here. And what that's going to do is this is going to go away because now it's just 1. Okay, and this part right here, I'm going to have to do that KFC on it, that keep flip change, okay, for this part right here. So I'm going to move over to the side right here so I can show this work. I'm going to just kind of rearrange this. X equals, I'm going to copy all this, 4 divided by 2 over 3. And that was our fraction line right there. Okay, so when we do keep flip change, we keep the top one. So this is like our top fraction. Okay, so it would be 4. This is our K. We flip the second fraction. So I'm going to flip the second fraction. That's our F. Okay, and then we change this to multiplication. So that's our change. It should actually be KCF, but we say KFC because it reminds us of churches or KFC the chicken, I guess. I don't know. So anyway, from here, we're going to go ahead and multiply normally. So remember that when we're multiplying fractions, all we have to do, if we're missing a denominator, we just put it over 1, okay? And we multiply straight across. So 4 times 3 is 12. 1 times 2 is 2. And 12 divided by 2 is 6. So in this case, my answer is x equals 6. So that means that on this one, the graph, let's see, it's also a linear graph at 6 over here somewhere. Okay, this is where f of x is equal to 0, or y equals 0, whatever you want to use. And it looks like this graph is it's positive, so it's probably something like that. Okay. If you're not sure where I'm getting these lines from, guys, I'm using my slope and my y-intercept. So the y-intercept is -4. So I know it's somewhere down here. And I know that this is a point because I just found it, 6, yeah? So the line has to go through those 2 points. Okay? This is just kind of extra though. All right, letter C. I'm just going to go ahead and recopy it because I know the paper, we can't see it right now. So letter C was f of x is equal to x squared minus 11x plus 18. Okay, and this one's a little bit trickier because it has a square and we tend not to like those. So what I'm going to do is the same thing. I'm going to set this equal to 0. So 0 equals x squared minus 11x plus 18. Okay, and in this case, I would not move anything over. You're going to have to factor. Okay, so we're going to have to factor here. And we've done this once or twice, I think, so far. So the factoring looks like this, where you have the 2 parentheses. We're going to factor this trinomial into 2 binomials. So 3 terms into 2 of them, okay? So we have to find a number that multiplies to the 18 that also adds up to -11. Some of you who had me last year used to call this Texas because it looks like a T and an X. It has to add to the -11 and multiply to 18. So in this case, it looks like those numbers are going to be 9 and 2 because 9 times 2 is 18 and 9 plus 2 is 11. But since it's -11, we have to make it both negative. And that still works because -9 times -2 is positive 18. Okay, so this is the factor part. And now we need to solve it because for the solve, we should have an x equals, right? So what we do is we take each of these parentheses and we set them equal to 0. And then we just solve it. So we add 9 on this side, so x is equal to 9. We add 2 to this one, so x is equal to 2. And that means that this graph, I'm going to scroll down a little bit more, is going to pass 2 times through the x-axis, okay, at 2 and at 9, something like that maybe. And I don't know, it might look something like this. And notice that this is going to be like way up here somewhere, which makes sense because 18 up here is our y-intercept. Okay. Again, the graph I'm just doing kind of extra. I'm trying to relate it because you're going to see this later in the future. Okay. But these are the x values where f of x is equal to 0 or where, it crosses the x-axis. We have one more, and I'm going to do it right here, right next to it, because we have room, a little bit of room. And this one is f of x is equal to x squared minus 36. So this one I chose on purpose because we always forget this. It's actually very simple, okay? It's the same as letter C, but we're missing that middle term. So let's go ahead and just set it up first. We have 0 equals x squared minus 36, okay? So we replace f of x with 0, and then we're going to factor it. So just like we did letter C, we're going to factor this one, okay? But this one is missing that middle term. So that means that whatever numbers I choose, they cancel each other out in the middle, but they multiply to 36. So a really quick way to do this is just to take the square root of this perfect square. And in this case, it turns out to be positive 6 and negative 6. And if we were to multiply this out, you would see that this is going to give us x squared, the outside, minus 6x plus 6x, and then minus 36. So we can see that these two terms in the middle cancel out, and we're left with this. So we're good to go, okay? Then we just go ahead and solve like the problem before. So x plus 6 equals 0, x minus 6 equals 0. Subtract 6 on the first one. We get x is equal to negative 6. Add 6 to the second one. We get x is equal to positive 6. And this is where our graph crosses the x-axis. So it might look something like this. I cannot draw a line through a point. There we go, something like that, okay? And again, these are the points where f of x is equal to 0. Remember that f of x is the same as y. If we check, we see that this is the x-axis, and y is always equal to 0 here on the x-axis, because no matter where you pick, y is going to be 0, okay? All right, next example. Now we're going to be finding values where f of x is equal to something else. So in those examples, f of x was equal to 0, to a natural number, also equivalent to the x-intercept. Here, we're going to make f of x equal to another function, and we're going to call it g of x. Okay, so find the values of x for which f of x is equal to g of x. Graphically, this is kind of like where the graphs intersect. It's kind of like solving a system, okay, but we're dealing with two different functions, and they're not necessarily lines. In this case, I think I actually chose quadratics just to give us a little bit more practice with quadratics. So go ahead and copy this down. We have that f of x is equal to x squared plus 1, okay? And g of x is equal to 3x minus x squared. So all we have to do is kind of follow what it says here. We're going to set f of x equal to g of x. So exactly what I underlined is what I'm going to set equal. Here's what it looks like. X squared plus 1, okay, equals 3x minus x squared. And we're just going to solve for x, and we're going to see what is x equal to for this to be true, okay, because that's what we're looking for, the values of x when this is equal to each other. So I'm going to start by combining like terms. I'm going to move everything from the right side to this side, because they're both x squared, so it's not really going to help us if we do a negative. So positive x squared, that's gone, positive x squared. And that's going to give me 1x squared plus another x squared is 2x squared plus 1 equals 3x. Okay. Then I'm going to go ahead and move this 3x over here because I see that this is probably going to be a quadratic. And when we do deal with quadratics, we can usually factor. Okay. So this is going to look like this. 2x squared minus 3x plus 1 is equal to, well, I got rid of all this, so now it's equal to 0. And now that we have a quadratic, we can go ahead and try to factor and solve, just like we did the problem before at this point, okay? Notice that even though this is on the left side now and this is on the right side, the 0, it doesn't matter. We can still factor. So the factoring, this might be a little bit of a review for you guys, okay? What we're going to do for this one is where we can do several different methods. You can guess and check, okay? In other words, you know that for sure you have an x here, for sure you should have a 2x here, because we have to have that 2x somehow. And then you have to kind of play with the numbers here to make them add up to -3. Remember, this is the, use a different color. This is where it has to add, and this is where it has to multiply. But because we threw in that 2 here, it complicates the multiplying part, okay? So that's why I'm saying we can guess and check the numbers. We know for sure that the 1 is, to get a 1, it's 1 times 1, okay? So we know for sure that it's probably going to be a 1 and a 1, and then we have to figure out the sign. So let's go ahead and do that. So 1, 1. I want to get a positive 1, so, but I have a -3 here. So that means I have to have a negative in here somewhere, okay? The only way to get a positive 1 with a negative involved is if I make both of these negative, because -1 times -1 is positive 1, okay? So let's check to make sure everything else worked out. If I did 2x, let's see, the outside, 2x times -1, that's going to give me -2x, okay? And the inside, -1 times x, is going to give me -x. And if we add those up, that's -3x. So it looks like this combination is going to work, okay? Before I move on, because I know I probably lost some of you here, this is the guess and check method for factoring. I'm going to show you another way, because I know some of you guys are more familiar with this method. I'm going to put it a little bit higher just so we have the room. Okay, so this was the guess and check method. This one is called slide and divide. And I think this is what I showed my students last year. Slide and divide, when you have a quadratic like this, what you're going to do is you're going to slide this number over here and multiply. So you get x squared minus 3x plus 2, because 2 times 1 is 2, okay? But this 2, we're not just going to get rid of it, we're going to hold on to it up here somewhere. So we have our 2 up here. You have to kind of keep it safe, okay? So this is our new quadratic, and this is easier to factor. Writing kind of small because I need it all to fit here. So this would be x and x, and if I want a 2, well, I'm going to have a 2 times 1, because that's the only thing that will give me 2. Since it's -3, I'm going to make both of these negative, because a negative times a negative will give me that positive, but if I add them, they give me that -3, okay? So from here, we're almost done. You're going to bring back this 2 now. So the 2 that I was holding on to here in the corner, we're going to bring them back and we're going to divide. That's why it's called slide and divide, okay? So what happens is we can reduce this part, because 2 divided by 2 is just 1, so it's going to be x minus 1. Okay, and this guy can't stay there, so we actually need to move him back up to the front. So it's 2x minus 1. And if we notice, this is exactly what I got over here. So these two methods are going to work. Me personally, I used to use this one, the guess and check, only because I was really good with numbers and I could do all this in my head. But if this isn't working for you, this will always work as well. You just got to know the method. Okay. All right, so we're almost done with this part of the problem. We still have to solve, okay? Whatever method you decide to use, you still have to solve it. So I'm going to go ahead and set this equal to 0. Okay, and let me cover that bottom part so you're not distracted by it. So I'm going to set them equal to 0 and I'm going to solve. So for the first one, I would be adding 1. And I apologize for it. It's kind of small right now. So that's going to go away. And this would be 2x. I can't do this. I'm going to move that. This would be 2x is equal to 1. Okay, because 0 plus 1 is 1. You would divide by 2. And I know it's super tiny right now. Sorry about that, guys. You know what? Let me do this one in a better spot because it's kind of hard to see. So I'm going to move it up here to a corner. So we had 2x minus 1 equals 0. Okay. So plus 1 plus 1, 2x is equal to 1. Okay, divide both sides by 2, so x is equal to a half. So that's one of the answers. Okay, the other answer is easier to see because it was just x minus 1 equals 0. So I just have to add 1. X equals 1. So that means that this graph, if you graph both of these guys, okay, they're going to intersect at these points right here. That's where they're going to cross. Okay, and I'm guessing based on what I'm seeing, it's probably something like probably, let's see, 1/2, 1. So probably something like this. I don't know, something like that, where you have two parabolas crossing at those points. But don't worry too much about that again, like I said. So yeah, that's it for this one. A lot of work. Okay, we're gonna do one more of these crazy ones. Hope I can get it all to fit a little bit nicer than the one before. Go ahead and cover that so we know exactly what we're doing here. Okay, so we have our problem here, and it's the same deal. We're going to set this guy equal to this guy over here. So let's go ahead and do that. We have x squared. I'm going to go ahead and work on this side so I have room over here. So x squared plus 6x minus 24, okay, equals the other side. So 4x minus x squared. And we do the same thing. Okay, we just go ahead and we're going to combine like terms. So I'm going to go ahead and move x squared over here to the left side. And while we're at it, I'm going to move the other guy also. So this saves us a little bit of time. And I think I used to do this in my classes last year to kind of to reduce the work. You can go ahead and move the 4x also, because why not? And that'll get rid of this and this for us. Okay. So on our second step, we already have that 0 that we wanted. I'm going to combine all of this. 1x squared plus another x squared is 2x squared. Okay. 6x minus 4x is 2x. Bring down that 24. Okay. And here is our quadratic. Just like the one before, at this point you would be factoring and solving. But I'm going to show you a trick for this one. So the one before, the problem that we had before, okay, just really quickly, was 2x squared minus, so it's all this, minus 3x plus 1. 2, 3, and 1 are, they have no common factors, so we really can't do anything shortcut with those. We have to go through the whole process. But this one, we have 2, 2, and 24. So all of these are divisible by 2. So if they're all divisible by whatever this number is, we can actually divide out that 2. So I'm going to divide out a 2 here. As long as you do whatever you do on the left side to the right side, you're allowed to do that. Okay, so here, just to make a side note, we're going to divide everything by 2. That's what I did right here. Okay, and that's going to help us out because it makes our life so much easier. So this is now x squared. This is just x, so plus x. Okay, minus 12, because 24 divided by 2 is 12, is equal to 0 divided by 2 is just 0. So isn't that a lot nicer? I hope it is, because I know for me it is. And this is a lot easier to factor. So from here, I'm going to go ahead and do my 2 parentheses. And I'm going to figure out what numbers are going to give me, are going to multiply to negative 12, okay, and add up to positive 1. Remember that if there's no number, there is an imaginary 1 there, okay? So those numbers are, I believe they're 3 and 4, because 3 times 4 is going to give me that 12 somehow. And if I subtract them, if I do make one of them negative and add them, I'll get that 1. So here's the 3, here's the 4. If what I just said threw you off, here's another way to think about it. This is negative 12, so one of these has to be negative. That's the only way to get a negative 12. Look at your middle term. If the middle term is positive, then your bigger number is also positive, and that means 3 is negative. And if we check, 4 minus 3 is 1. Negative 3 times 4 is negative 12. Okay. Hopefully you remember some of this because this is algebra 2 stuff, okay? We're going to go ahead and set this equal to 0 now. So x minus 3 equals 0. X plus 4 equals 0. This step might seem a little bit tedious because I know that a lot of you know it's just the opposite, but it's good to practice it for when we have fractions, like the problem before where we had a half. Okay, so we're going to add 3, x is equal to 3. That's one answer. Subtract 4 for this one. X is equal to negative 4. That's the other answer. So this one, like the one before, also has two answers. So it means that if we were to graph both f of x and g of x, which was, the blue guy and the pink guy up here, they're going to cross at these x values. Okay. And that's it for this one. I believe we still have a few more examples. Yes, we do. So let's try to get through that. This might be the longest video yet. Here we go. Domain of a function. Go ahead and copy this down. While you're doing that, I will note that you are going to be able to use a graphing tool for this one because we haven't quite talked about the different functions. So let me go ahead and get that ready for you. All right, so here is our calculator. And remember, this is something you can download on your own phone using that WabbitEmu description in one of the attachments on your Google Classroom. If you don't know where to find it, let me know and I can show you how to do that. Okay, so we're going to go ahead and graph this first one. F of x is equal to the square root of x. You want to go to y equals, which is up here in this corner. Okay, and we're not going to do f of x. Remember, f of x is the same as y. So all I'm going to do is I'm going to graph that square root of x. So second, and then square root, and then x, and then just close the parentheses. And we're going to graph it. The graph is here in the other corner. So there it is. So it looks like it kind of starts at 0 and it goes on forever. If we look at the table, so you press second graph to get the table, you're going to see that all of the negative numbers actually have an error. Okay, and there's a reason for that. You can actually see where the numbers start. They start at 0, and then it just goes, up from there. Graphically, again, it starts at 0. So this graph looks like the domain is going from 0 to infinity. Okay, if you want to use the different notation, you can also use this notation if you prefer. Okay, and a quick sketch. So it looks something like that. Okay, using the same thing, we're going to find this graph now. So going back to my little handy dandy calculator, I'm going to go to the y equals, and I'm going to clear that. Since it is a fraction, we have to be careful when we're doing this one. It's not like the fancy ones. We have 1 divided by, I'm going to put all of that denominator in parentheses. So x squared minus 4. Okay, and close the parentheses. Okay, we're going to see what it looks like. It's going to look a little weird. There we go. It looks kind of weird. Okay, so let me try to zoom in on that. Let me see if I can remember how to do that. Zoom. And we're going to zoom in. There we go. That's a better picture. So this might look a little familiar to you from last year. It's actually a rational function. And you see these two lines right here. So there's this vertical line and this almost vertical line. These are actually what we call asymptotes. And hopefully you remember those words. And it's a little misleading because there is nothing here, but yet the graph, this calculator is showing us there's a line there. Well, the line represents an asymptote. So what's happening here is that this graph looks kind of like this. It has an asymptote at -2 and an asymptote at 2. Okay, something like that. And the graph is doing something like this. I know, crazy, right? So, but this is a rational function. That's why it looks kind of weird. So the domain for this one is actually going to be in 3 different pieces. We're going to have everything on this side, everything in the middle, and everything over here. If we didn't want to write all that, another way we could do this is we can say it's all real numbers, so it's everything except for -2 and 2. So let's go ahead and do it a couple different ways. I'm going to do the one that kind of has all three pieces. So we would say negative infinity to -2, and I'm going to put a parentheses because it doesn't actually go through -2. Unite it with this piece in the middle. So -2 through 2. So that's everything in the middle. Also unite it with the rest of it. So 2 through infinity. So this is one way that we could write our domain. Okay. Another way that we can do it is we can say, well, x is everything. X is all the real numbers except for, so this means except, okay, -2 and 2. And that might seem faster, but you do have to make sure that you're doing your notation correctly, okay? So different ways to do that. If you don't remember how to graph something like this, like I said, that's fine. Use a graphing calculator for now, just to kind of give you a quick insight. This part right here, to find the, I guess you could say the holes or asymptotes, what you do is set the bottom equal to 0, x squared minus 4 equal to 0, okay? And if we factor this, we should get x positive 2, x minus 2, and when we solve, we get our two numbers right here. Just to kind of insight on what's coming up very soon, okay? All right, so with that in mind, we're going to talk a little bit about our domain now. The implied domain, okay, is the set of all real numbers for which the expression is defined. So as you saw in the examples we just showed, okay, the domain will exclude x values that result in division by 0. So that's the example 10b. So the one that we just did, the reason that these are not included, okay, is because if you were to put this -2 right here, so if you were to say 1 divided by -2 squared minus 4, okay, if you were to plug it in, well, this is the same as 1 over 4 minus 4, which is 1 over 0. And this is a big no-no. This is undefined. You can't do that. So this is the reason why this number and the 2, because it's the same thing happens with positive 2, that's the reason why that's excluded from the domain, okay? The same thing happens, not the same thing, but something similar happens to the even roots of negative numbers. So in the first example where I showed you the table with the error, we can't take the square root of a negative number. If you try, you're going to get an error, and we saw that in the table. It doesn't exist in the real number plane, okay? It's just some things to think about there. We're going to go ahead and do a few more examples. Find the domain of the following. F of x is equal to 1 over x plus 2. So this one is really similar to the one we just saw. Using the information that I just told you about, we can't have a division by 0. All I would need to look at is this bottom expression, okay, and find where that is equal to 0, okay, like so. So I would just, solve, and that gives me x is equal to -2. And this is exactly where my domain would not be existent, because if you plug in -2 plus 2 is 0. So in this one, my domain is x is all real numbers except for -2. Oh, and I almost forgot, you can also do this another way. You can also just say x can't equal -2. So either one of these is correct. This is probably shorter because, we're lazy by nature and we don't want to write so much, but whichever one is fine, okay? All right, letter B. I really like this problem because it's more of a context problem. It says the volume of a sphere, V equals 4/3 pi r cubed. So in this one, obviously, we would be using our x would be like the r, okay? But I'm going to tell you straight out, like, without even graphing it, that the domain for this one is pretty much just wherever r is greater than 0. Because, so r greater than 0 is our domain. Because in this one, we want to think about the physical context that we're given. It's telling us the volume of a sphere. You can't have a negative radius. That would not make any sense. Graphically, you might see, when we draw circles and stuff, you might see, well, they're using the negative numbers, but we weren't actually speaking about, the physical context of it. So for this one, you can go ahead and write this. So because of physical context. Okay, r is greater than 0, which is what I have right here. Okay, and if you want, you can put in parentheses, we cannot have a negative radius. Okay, and that is it for that. Okay, I think we have one more example, maybe two. Looks like we might have two actually. All right, bear with me, guys. We're almost there. These are the application problems. Hopefully, it doesn't take too long. This might take you a little bit to write, so go ahead and pause if you need to here to copy all this. I'm going to zoom this up a little bit so you can see everything. Maybe a little bit more. There we go. Okay, so it says that a second baseman throws a baseball toward the first baseman 60 feet away. This is a 6. Okay, so 6-0. The path of the ball is given by this function here, where f of x is the height of the ball and x is the horizontal distance from the second baseman. The first baseman can reach 8 feet. Will he have to jump to catch the ball? So here's what we're trying to find. Let me go ahead and draw a little bit of a picture here. We have I'm not too much of a baseball person, but we have our first, let's say first baseman here. This is our first baseman. And our guy here, okay, has his little catcher's mitt. I don't know what it looks like, something like that. Looks like a heart, but this is the mitt, okay? So if he reaches up, this is 8 feet, okay? And our second baseman, he's somewhere over here, okay? I'm just gonna put a baseball cap for this one. So our second baseman, I guess we can give him a body too. There we go. He's gonna throw the ball to this guy, okay? And the question is, will this, let's call him Bob. Okay, so Bob, this is Bob and this is Tom. So when Tom throws the ball, is Bob going to have to jump or can he just put his hand up and catch the ball? So this point right here, this little point right here is the height of the ball at that point. So we also know that this distance is 60 feet. Okay, now the path of the ball is given by this equation that, I'm sorry, this function that we have right here. So what we need to find is we need to find the height at this point right here. Because if that height is less than 8 feet, well then yeah, Bob will be fine. If it's equal to 8 feet, he'll be fine. He can just reach up and catch it. But if it's more than 8 feet, then he's gonna probably have to jump a little bit, okay? So to do that, we're going to find, okay, the height when x is equal to 60 feet. Because this point right here is the cross section right there at 60 feet. Okay, so all I got to do is plug it in. So f of 60, okay, is equal to all this, negative 0.004 parentheses 60 square plus 0.3 parentheses 60 plus 6. And obviously for this one, you might definitely want to use a calculator. I'm going to go ahead and pull out my handy dandy TI-83 again and show you how to do that. Hopefully it works fine. So here it is. We're just going to plug all that in. Looks like I have, let me try to get all this on the screen. I'll try my best. So it looks like I have negative, so negative point. You'll have to follow along with your paper here. So negative 0.004 parentheses 60 close parentheses square. Where's my square button here? There it is, square. Okay, plus 0.3, so 0.3 parentheses 60 again, close parentheses, plus 6. I'm going to recommend you guys do practice with this calculator because it takes some time to get used to, okay? So there it is, 9.6. So f of 60 is equal to 9.6 feet. which means that this is greater than 8 feet. So the answer is Bob going to have to jump? He's going to have to jump at least 1.6 feet. So the answer is yes. Bob, and we just named him Bob. You can name him whatever you want. Bob will have to jump because the ball will be at 9.6 feet. Okay. All right. Almost done, guys. Almost done. One more problem. Last application problem. This is actually a really good one. I was kind of happy to see this in the textbook. I did kind of change it a little bit. So this is an application for calculus, which I'm hoping a lot of you will be taking next year, and it's called the difference quotient. So you have this like weird looking fraction up here, and this is actually part of the definition you're going to be learning hopefully next year that deals with derivatives. Okay, so I won't give you too much about that. I'll let the calculus teacher take care of that. But what we're going to do is we're going to evaluate a difference quotient using this definition where where h cannot be equal to 0 because if this is 0, remember it's undefined, using this example. So here it goes. We have that f of x, and I'm going to go ahead and kind of highlight all my x's here, is equal to x squared plus 2x minus 3. We want to find all of this. So x plus h minus f of x over h. So what you're going to do is you're going to do this in two pieces. You're going to write all this out. So you're going to substitute all of my x's with this guy minus the original divided by h. So what we're going to do first is we're going to find f of x plus h first. Okay, so I'm going to substitute this into all my x's right here. So here's what it's going to look like. F of parentheses is equal to parentheses square plus 2 parentheses minus 3. Okay, and inside those parentheses, we're going to put that x plus h. And we're going to evaluate the right side of this, so everything over here. Okay, so this part right here is going to be x plus h times x plus h, because there's two of them, plus, I'm going to go ahead and distribute this right off the bat, okay, 2x plus 2h minus 3. Okay, then we're going to go ahead and FOIL. So x squared, x times x, xh, so plus xh. The inside is also, it's hx, but it's the same thing as xh, so it's another xh. Okay, and then the last, plus h squared. So this is all this part. Okay, I'm going to go ahead and put this piece underneath, plus 2x plus 2h minus 3. Okay, so hopefully you're with me so far. This part right here, so you can kind of see what happened here. This part is all of this. Okay, now we're just going to combine like terms. So that looks like the following equals, let's see, I have 1x squared, so that's going to be by its lonesome. And then I have, I'm going to cross it out, I have 1xh here and another xh here, so that's a total of 2 xh's. Okay, and then these guys are just kind of by themselves. I can't really do anything with them, so I'm just going to write them out. And same with the h squared, so plus h squared plus 2x plus 2h minus 3. So this entire thing right here is going to replace, and I guess I can color code this. This whole thing right here is this, okay, and that is going to replace this part only. Okay, so now we're going to plug all this into this right here. F of x, we already have. F of x is just this piece right here. Let's see if I had more colors. So this right here is just this right here. So I'm going to plug everything in now, okay? And by the way, if you do have trouble with this one, it's all right. Let me know, because this is actually a calculus topic that we are lucky enough to see in our textbook. So we're going to start. I'm going to rewrite it first. F of x plus h minus f of x over h. Okay. And we're going to plug everything in. So my f of this part right here, okay, is all this. So let me write that out first. Let's work this out a bit. X squared plus 2xh plus h squared plus 2x plus 2h, oh, h, that's an h, minus 3. So all of this is that first part, okay, minus f of x. Remember that f of x is the original function, so minus parentheses x squared plus 2x minus 3, okay, divided by h. Okay, so just to kind of reinforce, this part right here is the f of x plus h, okay? And this part right here is the f of x. That's all. I'm just substituting right now, okay? So now I'm going to go ahead and simplify where I can. It looks like the top part is going to stay. I'm going to leave this part the same for now. So x squared plus 2xh plus h squared plus 2x plus 2h minus 3, okay? And I'm going to distribute this negative right here. Remember, this is the same as a negative 1. So minus x squared minus 2x plus 3. Again, all over h. Okay. Now we're going to combine like terms. So you want to make notes for yourself here. We distribute here, and we're going to combine like terms right here. So let's do that. It looks like I have an x squared here, and I have a negative x squared here. So that's going to work out nicely because they just cancel each other out. So those are gone. Okay. Then I have 2xh. Let me see. So I have this guy here. And I don't think I have any more 2xh's in here. So 2xh is by his lonesome here. So 2xh. Cross it out. H squared. I don't have any more h squared, so I'm going to go ahead and bring that one down too. Okay, 2x, so now I'm looking here at the 2x, and it looks like I have a negative 2x here. So this 2x and this negative 2x are gone. Okay, 2h is next, so let's see, I don't have any more h's. So plus 2h. And finally, we have negative 3 and positive 3, which happen to be opposites of each other. So that is also gone. So it looks like the top is just this part now, okay? And this is all divided by h. Now you might think we're done, but we're not. Okay, so maybe two more steps. Notice that all of these terms, so 2xh, h squared, 2h, and h, they all have an h. So what I'm going to do is I'm going to factor out an h on the top. Okay, I'm going to take out the h from these three terms, which leaves me with 2x plus h plus 2. This h is still the same. Okay, so on this step, I factored out h. Okay, I used greatest common factor for that. Okay, and then you're going to notice that the h's here cancel out. So my final answer for this enormous problem that I'm hoping was a little bit exciting for maybe at least one of you, okay, is the following: 2x plus h plus 2. comma, h cannot equal to 0. We do have to include that disclaimer there. And that is it. That is the end of this video, guys. Hopefully it was not too long. Let me know if you have any questions.